another typical empirical formula determination is for the combustion of organic compounds. So any organic compound such as here we got menthol, and some of the students will just think methyl is methane. No, methyl is a no compounds that it contains carbon, hydrogen, and oxygen. So in this way, we can just assume that it's CXHYOZ. And now let's see. So when the methane, these organic compounds, complete combust because it contains three kinds of elements, carbon, hydrogen, oxygen. So when CXHYOZ, it completely combust, it will produce CO2 and water. Okay, this is an unbalanced equation. The first method is that you can just try to balance it with using x and y to present for the coefficient, but I don't think it is a good method because the solving of this question is a little bit complicated. Another way is that we can see the number moles of carbon in this menthol organic compound will just be equal to the number of moles of carbon in carbon dioxide, and it is true for hydrogen. So we can use this kind of relationship to solve it. The first step is that we can work out the number of moles of carbon will just be equal to the number of moles of CO2, because in one carbon dioxide there's one carbon atom present, and it will be equal to its mass, which is 0.4419 divided by its molar mass, while the number of moles of hydrogen similarly will be twice of number of moles of water, because you can see in water there are two hydrogen atoms, right? So it will be 2 times its mass 0.9 and divided by the molar mass of water. So this is what we need to do. So first, and then we use the calculator to calculate it. It will be 0.1049 divided by please pay attention that the atomic mass, you need to use what is provided in the data booklet, and it should be 2 decimal places. Okay, so this is 0.0101 mole, and the second one is 2 times 0.1814 and divided it by Okay, so here it is 0.0204 more. Okay, so this is, I think, is easy to be understood. And the next step is that we need to solve the number of moles of oxygen as well. And some students may assume that, oh, well, we can just use the number of moles of oxygen can just be equal to the twice of number of moles of CO2 plus the number of moles of oxygen. No, you cannot solve it like this, because oxygen here also provides oxygen. So here we can only work out the mass of oxygen first, and the mass of oxygen will just be equal to the total mass of the metal, and to minus the mass of carbon minus mass of hydrogen, and that will be 0.1595 minus minus hydrogen times. Okay, so this is how we solve it. Work out to the mass of oxygen first. And so the next step is that we will record to the number of moles of oxygen, and then the number of more oxygen will be mass of it to divide by its molar mass. So out of these 5 values here, the number most of carbon, the number most hydrogen, the number most oxygen, you can find that the number most of oxygen is the smallest, right? So now we will use the number most. Oh, yeah, looking solvent this way. Now our next step will just be number moles of carbon to number moles of hydrogen to number moles of oxygen will be equal to yeah. And then you can work it out. So it works 10 to 20 to 1, and the empirical formula will just be C10H20. Oh, guys, so this is the final answer.